Welcome to Installment 25 of writing a 6502 assembler in assembly language. Again, continuing from right from I left off, right from where I left off last time, I need to make sure that this label issue is solved. 2 episodes ago, we're working on error handling, and I changed the scanner so that instead of printing a message saying this is an invalid numeric label reference, it just goes ahead and returns it. And here, because I wanted this to be handled as an undefined label, right? And just to make sure you understand what I'm talking about. I mean, the problem is when the number, numeric labels look like this. But this number has to be between 0 and 9. So if you made it 12, this would be a bad label. And actually, this scanner will still print an error. This is a bad label. But what if I had this, and I had some code, and then I had, and whatever. I made a mistake. I put, I'm sorry, like this. Instead of 2B, I put 22B or something like that. Previously, the scanner would say this is a bad numeric label, but then there was really no way to recover from that error. So instead, what we're doing in this case, if this was 22, the scanner just, it prints out a message, this is a bad numeric label, and then it completely ignores it. It doesn't return it as a token. It acts as if there's no label on the line whatsoever, and it's going to return this as the token. And then, which is fine, because it's just like this is not a label, so it's not a valid label, so we won't try to define a label for it. We just pretend like it doesn't exist. Good. But here, I don't really know how to recover from it if this is, or I did not know how to recover it. If it just says this is a bad numeric label, then what do? There's still a branch to somewhere. Instead, I want it to be treated like an undefined label. So therefore, the scanner is going to go ahead and return it as a backwards reference to a numeric label, but the number is wrong. So at some point, it has to be treated like an undefined label. Okay, and so the way labels are handled in this, we have to go back several episodes to think about to the symbol table. But basically, if we're talking about a named label, and a label which is composed of, has a symbol associated with it, composed of letters and numbers, those things give you a symbol table entry. And anytime you try to access a label like that, the symbol table entry is created for it, so you don't have to worry about there being one. But inside the symbol table entry, there is a type, which tells you there's a byte which contains the type of the symbol, and it tells you this is an undefined label. Basically, it's an undefined symbol. And so that's how we know that. But here, in the case of the numeric label, that's not true. Instead, they are stored in these linked lists, which store only the value of the symbol at any given time. That's it. There's no type because it's a relative offset into the program somewhere, always. So we have to have some other way to tell that it's undefined. So let's look at this code, because I don't remember off the top of my head exactly how it works. All right, we're going to save a 0-page, make a 0-page location for us. And we get tokeval. Now, tokeval is the actual number that we're talking about. So here's where it can check this tokeval and see if it's actually a valid label or not. So right here, we can check to see if this is a valid label or not. And what it does, right now, this code assumes it's a valid label because it thinks that the scanner already checked to make sure. Okay, so it's going to return T forward, and it's going to return the value in tokeval. It's using the pointer here Yeah. It's using the pointer here to get the value of this numeric label and store it in Tocqueville, and returns it with like that T forward. So it looks like I'm going to have just a new token type, which would be undefined numeric label reference, something like that. All right, so if compare this to 10, if it's less than 10, go to for label 0. I believe that will be just fine. Yes, it will. For label 0. Otherwise, load with tund and return it. So that's going to be an undefined label, and it particularly means an undefined numeric label forward or backward reference. Okay, and we do the same thing here. This would be okay. Backward label 0. All right, and compare to 10. If it's less than 10, 0. Otherwise, tund RTS. Okay, save that. Load AS0 because that's where we define all these things, I'm pretty sure. T forward. Yep, there it is. Yeah, look, we're running out of spaces. Of course, I could just change them all. Yeah, make this A0 and B0 and B1. I'll do it if I have to. Okay, yeah. But for now, we don't need to worry about that. We still have 2 values available to us. Okay. Load AS2. All right. TNLab. Okay. So now this is actually in the expression parser here. If we get a for label, we go to statement 5, la 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 la. Okay, statement 0, 1, 3, 1, 2, 5. LC 6. Okay. Branch of quota statement 7. Okay, expression. All right, I think wait a minute. Hang on, what am I doing here? Handle assignment statement. Okay, that's here. Okay, so this is basically when I'm looking for a statement, I'm finding an expression. I have a name, goes to statement 5. Ah, yeah. Okay. If it's not that, I go to statement 7, which is seeing if it's the end of line. Okay. So an undefined basically an undefined numeric label reference is, I think, the thing to do here is just go ahead and treat it at this point, if it's okay. In other words, go into expression. Okay? Because we're going to catch it in the expression parser. In particular, in the term part of the expression parser. Term, is there not term 0? Term exp. Okay, here it is. All right, and here's what I put. Yeah, see, here's what I did. Make sure less than 10. Okay, I don't have to worry about that because if it's not less than 10, it won't come as this, it'll come as a t undefined. What will also happen if you get a name here, but the name happens to be undefined. Okay. Now at the moment, to do undefined. So I really would want to check and make sure this is where we have term exp2 is where we have a name, which is a regular symbol. But it could be an undefined name, which in the first pass is fine. We expect names to be undefined in the first pass. And the second pass, we expect them to be defined. Okay. The valid forward backward label. Okay, that's all good. Now, what if it's an undefined, like an undefined forward backward label? That would be this here, right? BQ something something something. Term exp9. This thing's getting kind of big. We might not be able to jump to everywhere we want to jump to. I mean, branch. Oh, I did say here, get label type undefined or defined. Yeah. That's all part of this stuff, okay? Here, let me put it here. Term exp9. Okay, so if it's an undefined label, then basically we want to treat it as if it has a value of 0, right? And actually I should make sure that that token value is 0 when it returns token undefined, so I don't have to set it here. But I just want to print a message if the pass is not the first pass, that it's an undefined label. Right? Yeah, and there's the whole thing of the type. Actually, in the future, the type will be different than this term exp1 here is a number. And in the future, the type of a number is going to be absolute, and the type of a label is going to be relative, which means that the type of the number can't be relocated. I mean, like if you have a number 5, that doesn't get relocated just because you link the program or have it at a different address or whatever, but the label will change if you link the program with other code or you set it up to run at a different address. The label will change, the address of some line of code will change. So basically this code looks good, except for the fact that this type is almost certainly wrong. But that may not matter. This is the case if you have a label which is a name, a symbol, and it's copying the type and value out of the symbol table. Okay, where do the forward and backward labels go? They go to 4, which doesn't set a type at all. So actually, let me just check and make sure term x4 okay, from the forward label, backward label, that's it. Okay, so this is numerical label central here. Okay, and that looks like that was just in the wrong place. But anyway. So I like this. So, okay, so here I'm going to JSR error. And then so the numeric label thing is going to say it's going to have error for undefined. And then it's just going to go ahead and put the stuff here, which will be token value 0, and the type of a numeric label is always relative. Now, currently, I'm writing the code to be everything absolute. There's no possibility of linkage or stuff like that, because I'm trying to very quickly get, well, not that quickly, but I'm trying to get something going so that I can use my own assembler to assemble itself. So we'll store that into expert type. This is the type of numeric labels. Okay, and then actually this error that I just typed in here quickly should only happen if it's not the first pass. You don't generate undefined label errors in the first pass. Okay, and I believe I just called the variable pass for that, and compare it with 0. 0 is the first pass. If it's not, I'm sorry, if it is the first pass, then we just skip over the error message. Otherwise, we're going to print the error message. Okay, so if I have an undefined numeric label, then we're going to check the pass. If it's pass 0, or that is pass 1, which has a 0 in the pass variable, we're just going to go ahead and continue. Otherwise, if it's the second pass, we'll print out an error, and then go ahead and do the same thing, basically. So we need undefined error, and we can put that down here. Undefined label. Okay. What did I just do? Okay. So this is the situation of numeric labels. Okay. Now this is the named labels right here. And what we do with those is the token value here for the named labels is a pointer into the symbol table. So we store those here. Store the pointer here. Okay, and then we load from bytes 12, 13, 14 of the symbol table entry. That's why this is 12 here. 12, 13, 14, which is the type and the value. We store those into our variables down there, the type and the value. So we're copying from the symbol table in there. Okay, and then when we're done with that, return. That's nice. But we need to check and make sure that it's not undefined. That's important. So at this point, okay, at this point, we should probably, so it's copied it all in there. We check the expert type. And we know that these things are undefined if they have expert type is 0, if their type is 0. Okay, so if it's not 0, we get the term x3a. Let's oh, it frustrates me because this code is right here, which is exactly what I want. It's just that I don't necessarily want it falling down here afterwards. Okay, so okay, so branch of not equal to, so if expert type is not 0, then it is defined. That means we're all good. It's just the label I'm worried about. I think it's annoying. Okay, now there's nothing I can grab onto. Okay, let's see. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is the case of, let's just call it term lab. Oh, I'm sorry, wrong place. Not here. Here. Okay, so if the type is not 0, that is it's defined, we just go to term lab. If it's not defined, then we have to load pass. If the pass is 0, no, I don't even need to do that. Don't need to compare. If pass is 0, then I'm not going to print a message. Go to term lab. Otherwise, load x, load y, undefined label error, just our error, and return. Yeah, maybe you see my frustration. This code here is basically identical to this code here, and yet combining them is not easy because this is the numeric label case where if it's going to take the toke val, which is the address of that the label refers to, and it's going to return whatever type of numeric label is, which is at this moment 1. Right? And then if it's undefined, it does all that and then just puts the 0, it's in toke val there and puts the 1 there. That's great. Whereas if it's a named label, what's in toke val is not a value of the label, it's just a pointer. And so I can't just come down here into this code. And also the type might be different completely. The type of a named label could be all sorts of things, not just a relative address inside the program. So I can't reuse this code here for that, which means I really can't reuse this code here because it falls directly in there. I mean, I could make a little subroutine that I call JSR, but just repeat it. All right, well, anyway, now here's where we copy the stuff. Now we see, hey, did we just copy and see it's an undefined label? If it's not, we're good. If it is, check the pass. If it's pass 1, we're good. Otherwise, print undefined label message and return. Okay, which means this to-do is taken care of. All right. These are the to-dos for the future. Change the type appropriately, blah, blah, blah. That's when we're actually handling different kinds of types. Right now, it's an absolute assembler. There's one type, absolute number. The other type is just undefined, which is not really type. Okay, and now I said we need to go back and make sure that in the case of this token tund, T-U-N-D, that the token value is set to 0. So let's save this. And that was in AS1, I believe. Tund. There it is. Okay, load tund return. So actually, whoops, before we do that, we need to load 0, store took file, store took file plus 1, then tund. And then again down here, same thing. Load 0, store took file, store took file plus 1. Okay. That looks good. All right, now just to check error, that's an unexpected token. And right. I feel like we already messed with that quite a lot. Or did we? I mean, this was the point where you have a statement, and at the end of the statement, you expect, I mean, you've completed a syntactically valid statement, you expect something to go between statements, like the end of a new line, a comma, whatnot. or into file. Right, and what I decided to do here was to, yes, unscan. If I get something which is not a comma or new line, I'll unscan it. And if it's into file, I'll go ahead and say good and return. Otherwise, I'm going to print out an unexpected token error. But having unscanned that token, I will now try to get another token. I will try to read another statement just as if there had actually been a statement separator. That was what we did there. I remember that now. And here's the expression complex. That took a lot of time, a lot more time than I thought. And I hope the code is good. I'll look at it a little bit, like off screen, just to make sure it looks okay. But that's all the error stuff. So I think we're all done with this error handling. I think it would be wise for me to go back and look at it off screen, think about it, make sure it acts the way I want it to act, and then, assuming that I don't find any problems, it'll be time to actually try to get this stuff working. That is to say, I should be at the point now where I can have a line like this. All right. I should be able to make a source file which has something like this. I think even something like this. Or whatever, and have these things actually work, right? And I should be able to almost make a little calculator where, it will print out the value of all of the expressions it sees. It'll print out a 23 and a 45 and whatever the ASCII value of a lowercase e is, and it'll print out the value of this expression and stuff like that. Okay? All the code should be there. So if it works, if the bugs are drummed out of it, it should be fine. So I don't know if it's been enough time to end this installment, but I'm going to go ahead and stop recording, and I'll come back after I've checked everything and see if I need to do more work on the error handling. And if I don't, then it's time to start making this, making sure this expression parser works. There's going to be bugs in it that have to be drummed out, but after that is done, then we'll have a nice little expression parser, and we will have basically handled everything except for the actual machine instructions, when that will come, of course, in the future.